the reason we like to think about the Apollo missions and our telescope is that the Apollo 11 astronauts left this on the surface of the moon. And that thing holds some reflectors. And why do we care if there's reflectors on the moon? Because from our 107-inch telescope, we shot a laser at the moon. Aha! Here's a picture of the laser going through the moon. We shot a laser at the moon. Now, it took a little bit of hunting around to get the laser light to hit a reflector that's this big at a distance of 250,000 miles. But eventually they hit it, and then it had to be the right kind of reflector. If it was just a mirror, think about this. Laser light would have come in from Earth, hit that mirror at some angle, and reflected off into space, never to be seen again. That's not what our reflectors are. Instead, they are prisms that are called retroreflectors. And what that means is, this is my prism. I know it looks like a gang sign, but it's a prism. Light comes in from any angle, it reflects internally, and it returns right back to its source. So, once we hit the reflectors on the moon, some of the light came back to our telescope. We could send a pulse of light to the moon and it would come back, and we could time that pulse and determine very accurately the distance from the Earth to the moon. So that process is called lunar laser ranging, and it was something we started right here with our 107-inch telescope. We continued doing laser ranging with this telescope for a number of years, and then eventually the laser was moved to our other mountain, over to Mount Folks. And then several years ago, lightning struck the telescope, and the decision, and I think also funding ended, so those things happened at about the same time. The decision was made not to repair the telescope, but we are continuing, and we will be doing more laser ranging in the future, and I will get to the reason why in a